On this example, we are using the law of sines to solve all possible triangles given these circumstances. Okay, so how's this going to work? Well, the first thing you should really do is draw the triangle. And I just mean draw any triangle. Nothing special about that triangle. And just put A, B, and C as the three angles. Any order, you can put the A in the top, whatever, doesn't matter. And then put in across from them. So across from A, put little a. And across from B, put little b. And across from C, put little c. See how the A is across from A, the B is across from B, and the C is across from C? We always set up the triangles that way. I don't mean there's a rule that you have to, but I mean that's what they're assuming on these problems. So they're assuming your triangle looks like that. So we have to follow their assumption. So we set that up. Okay. So then what do they give us from here? They tell us that capital A is 111 degrees. Right there. And little a is 27, and little b is 18. And they want us to find the other two angles and the missing side. How do we do it? Well, this is not a right triangle, right? There's no 90-degree angles, so we cannot use SOHCAHTOA. Remember SOHCAHTOA? Why can't we use SOHCAHTOA? Because that has hypotenuse, right? The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. Hypotenuse is the side across from the right angle. That's the hypotenuse. We don't have a right angle in this triangle, so we can't use SOHCAHTOA. So that's why we have to use law of sines. Are you understanding that difference? When we have right triangles, we use SOHCAHTOA. When we don't have right triangles, we use law of sines. So step number 1, I'm going to set up the law of sines, which says what? A over sine A is little b over sine of angle B is equal to little c over sine of angle C, right? 3 fractions are equal. A over A, B over B, C over C. They're in the same ratio. So I'm just going to use 2 at a time to do this. Which 2? Well, which pair do I already have? I have A with A, right? See, I don't have B with B. I'm missing this. I don't have C with C. I don't have either one of those. But I have A with A completely. So for sure I want to use the A with the A. So I'll use little a, which is 27 over sine of capital A, which is 111 degrees, equals. Now let's go with, you can start with B or C, it doesn't really matter. I'll do the little b. The little b is 18, right, over the sine of capital B. Okay, how do you solve this? You're going to go diagonal, diagonal, cross multiply. So 27 sine of capital B is 18 sine of 111 degrees. Good so far? Cross multiply, diagonal, diagonal when you have an equal sign. And now we're trying to solve for B. So divide by 27. Boom. We bring it over here. So right now we have sine of capital B is 18 over 27 sine of 111 degrees. Right? That 27 crossed out on this side. All right, now, how in the world, what are we trying to do? We're trying to get B alone, right? We're trying to find capital B. What can I do to get B alone? Well, that's easy, right? Can you tell from my tone I'm going to do something crazy? Probably, if you know me well enough by now. I'm going to come in and go, I know, this is wrong. You can tell by my tone. Just divide by the sine. Boom, boom. There we go. B's alone. No. Don't do that. That's wrong. It's a very common mistake, but it's false. Why? Because this is not multiplication. This does not mean sine times b, even though maybe it looks that way. It's not. What is it then? It's a function. It's like f of x. Sine of b is a function. You can't, for example, with f of x, you can't just divide by the f. It's not multiplication. It's function. We can't do that. Really common mistake. So what do we do then? If we can't divide, how do we get rid of the sine to get B alone? Well, what you do, let me bring it down one more line, give us room to do what we need to do. What you do to get rid of the sine is you do sine inverse. sine inverse on the left side, and you know you have no choice but to do the same thing to both sides, right? Because you got to keep the balance, right? If these two things were equal before and then you do the same thing to both sides, they'll be equal afterwards. And what happens when we do that? These guys cancel. Sine inverse is the opposite of sine. That's why we have inverse functions in mathematics, because it's the opposite and it gets rid of it. That way we get the b alone. And what do we do with this side? Just hit the buttons on your calculator, that whole thing. Make sure you're in degree mode, right? Because this is degrees. So degree, your mode needs to be degrees because that's 111 degrees. So hit sine inverse of 18 divided by 27 times the regular sine of 111. And I'm getting capital B is 38.49. How many places do they want us to round? They don't really say, do they? Right, they don't really say. So I'll just do a bunch. 49065 degrees. There's capital B. We got it. So 438, so you can put that up here. 38.49065. That'll be plenty. Just type in a whole bunch and that'll be safe. A whole bunch of digits like that. Okay, now we got to get capital C. How can we get capital C? We're going to subtract, aren't we? We're going to subtract. I think you know it. I think you're thinking about it. So, because triangle angles total 180 degrees, don't they? So therefore I have the 111, the A. So we have 111 degrees plus the 38.49065. Add those up. That's 49065 degrees. Then the missing angle, which one are we missing? C. So angle C will equal 180 minus the 149.49065, which is going to be what? 30.5093 degrees. So there's angle C by subtracting from 180. 30.50935. Okay, we got both the angles. Now, last thing, we're supposed to get side little c. How are we going to get that? Well, again, law of sines. And I've already got A with A. I'm going to keep using this A with A pair. And now I've got angle C with C, so I can do it. Right? So let's write it out. Step 3, law of sines, again, which is A over sine A is B over sine B is C over sine C. So which pair am I going to use? I'm going to use the A with A because we know both those, and C with C. A with A, C with C. So A with A, right here. What was A? Little a is 27 over sine of 111. 27 over sine of 111 equals C with C. I don't know little c, that's what I'm trying to find, over the sine of capital C, which is right there, 30.50935 degrees. Alrighty, so now we go diagonal, diagonal, cross multiply. So we get 27 sine of 30.50935 degrees is little c sine of 111 degrees. Last step, to get little c alone, divide by the sine of 111 degrees. Boom, boom. Little c is alone. Hit the buttons on your calculator, right? It's going to be all of this, because this is gone now. That'll be little c. I'm going to hit the buttons on my calculator. I'm getting, a nice clean 18. Just boom. 18. You know what I did is I actually used, for this right here, I use the answer button. If you have an answer button on your calculator, that's quicker and more accurate. I just hit 27 sine of answer because I had that last answer on my calculator. So it'll use all the digits and it's quicker. You don't have to type it in. It came out exactly 18. So little c is exactly 18. And so there we go. So how'd we do this? So we're using the law of sines because this is not a right triangle, so we can't use SOHCAHTOA because there's no hypotenuse. So we use the law of sines here, and we started with AA and BB, and we got down to this point where we had sine of B, and to get rid of that sine, we did inverse sine. We did inverse sine on both sides, right? Inverse sine here and inverse sine here. It canceled out on the left, got B alone, had to type all this into our calculator, and we got capital B. And then we added up our two angles and subtracted from 180 to get our third angle. And then we went back to the law of sines again, A with A, C with C, and we were able to solve for little c. There we go.